In lesson 57, we're going to find perimeter and area of polygons that are on a coordinate grid. Now, to find a perimeter, all you have to do is know all the side lengths and add them together. And so in example 2, it says find perimeter of rectangle EFGH in simplified radical form is how we want our answer. And so perimeter, we need all the side lengths. Well, this rectangle is slanted. There's actually an easier one in example 1 where it's not slanted at all, and so you can just count the distance, but we skipped the redundant one to this one. And so how can we find the length of our sides? Well, what we can do, find the distance between two coordinates, is use our distance formula. So let's say we're finding the distance between E and F. Distance between E and F. Well, our distance formula equals x2 minus x1. So 2 minus 1 squared plus y2 minus y1. And then you solve. 2 minus 1 is 1 squared, 1. Negative 3 squared, 9. So square root of 10 is EF. Now it actually already gives us a hint here by calling it a rectangle. Well, properties of a rectangle, if you know those, opposite sides are congruent. So if this is radical 10, we know that this one is also radical 10. So you can take a little shortcut there as long as you know properties of a rectangle. So there's distance D of EF. Now we need to find the distance of, let's do FG. Okay. X of 2 is negative 4. Oops. X of 1 is 2, so negative 4 minus 2 squared plus y of 2 negative 2 minus 0 squared. And now we solve. Negative 4 minus 2 is negative 6. Negative 2 minus 0 is negative 2 squared. So we get 36 plus 4. And we get square root of 40 for FG. Now I'm going to go ahead and it wants us to simplify the radical form. I actually know radical 10 is simplified because its two factors are prime numbers. But radical 40, we can go ahead and actually simplify that. Factors of 40 are 10 and 4, 2 and 2, and then 2 and 5. So we can take out 2 2's to make one whole number 2, and we're left with radical 2 times 5, 10. So the measure of these sides are 2 radical 10, 2 radical 10. So now that we know all four side lengths, we can add them together. So we do radical 10 plus radical 10 plus 2 radical 10 plus 2 radical 10. Well, they all actually are like terms. They all have radical 10. So therefore we can add the numbers together. 1 plus 1 is 2, plus 2 is 4, plus 2 is 6. And then we keep the radical 10, and that is our perimeter. So that's how you do perimeter of a polygon inside of a coordinate grid. Now let's look at area. If we're solving for area, example 3 says find the area of right triangle ABC, so it gives us a hint there, with angle BAC being your right angle. So I went ahead and drew the triangle, and I'm going to go ahead and put our right angle in its place. Our right angle is at angle BAC, so right there. Now if we're doing area of a triangle, well, what's our formula for area? A equals 1/2 base times height. So that means we only need 2 of the side lengths. We need our base and our height. Well, our hypotenuse is always opposite of the right angle, so therefore we do not need that line. We don't need to find the distance of the hypotenuse. That's unnecessary work. So let's find the area of the base first. This would be our base. So we do the distance formula again. Distance of AB equals x2. We'll do -1 minus 1 squared plus y2 is 2 minus 3, or y1 is 3. -1 minus 1 is -2 squared, positive 4. 2 minus 3 is -1, so plus 1. So therefore, my base equals radical 5. Then we look at distance for our height. Our height is, AC. So distance there, x of 2. X of 2, we'll call it 3. X of 1 is 1. Y of 2, -1, minus 3. 3 minus 1 is 2 squared, and 2 squared is 4. -1 minus 3 is -4, and -4 squared is 16. So therefore this is radical 20, square root of 20. Now I'm actually going to go ahead and simplify that radical, because 5 and 4 are not prime numbers. So this simplified would be, take the 2 2's out, and it'd be 2 radical 5. They're the same thing, I just simplified. And now we know our height. So we plug it into our formula. Area equals 1/2. Base is radical 5 times 2 radical 5. Well, we can do 1/2 of 2 and cancel those, and we're left with square root of 5 times square root of 5 equals area. Well, we know square root of 5 times square root of 5 is just 5, so the 5 units squared for our area. And that's how you do area with coordinates. Now I do want to show you one other thing that the lesson has. It's probably going to be easier to follow in your book on lesson, for example 4, page 376. We're going to look here at the book. It says, let me try to get it to where you can see. Okay, and we'll see how this goes. Hopefully this works well. It says estimate area with coordinates. And then it gives us our figure here. Well, when we're doing estimation of this area, what we want to do ultimately is we're just counting. And it's as easy as that. So in this figure, you can see how they count. 1, 2, 3. They're looking for all the boxes or the squares that are completely inside of the composite figure. They count 10 squares. Next, what they do is estimate the area of the remaining space. So one thing they do is look for a triangle. So you see this triangle here. Well, over here it was empty. So they're estimating that that triangle could be considered one square unit. And so now we went from 10 and we added 1. And then it does that throughout the rest of the ones. And you can kind of look and see how it does it. It's probably easier than me trying to hold this camera here. We'll look at an easier one and just kind of get a glimpse of it. For B, it says estimate the area of this figure. So what I'm going to do is I'm going to count all my squares here. 1, 2, 3, 4, 5, 6, 7, 8. Those are easy to see. Well, then this one's completely in. 10, 11, 12, 13, 14. So we have 14 squares already. Then I'm going to estimate what the amount of, like, this little area here, what all these areas add up to be. Like, this is a pretty big area. That's almost 1 in and of itself right here. And so to me, those basically add up to be 2 square units. So I estimate that it's roughly 2, and we get 16 square units like we have here in the book. And so that's how you do estimating. You're basically just counting what's inside the composite figure and then adding on to it whatever else you see. And that's all we're going to do in lesson 57, but hopefully you understood the estimation part. It should be pretty easy.